2, the law of cosines. So this works for side angle side and side side side. So if you're given basically two sides and an angle that doesn't go with either of those sides, it would be side angle side, or side 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 where you're given all three sides and no angles. So the law of cosines if triangle ABC has sides of length A, B, and C, then, and I'm just going to draw a triangle over here really quick. There we go. Basically, these are going to be the different formulas. It's the same formula, but it's written based on what information we're given. So A squared equals B squared plus C squared minus 2BC cosine A. So the first part looks a lot like the Pythagorean theorem. It's obviously not, but it looks a lot like that. And then it's minus the two times the side lengths of whatever we're given, and then the cosine of the angle that was given. So this one would be solving for side length A, which would be that you've been given all of these other pieces. The other one, turn this thing off so I'll get rid of the box. B squared equals A squared plus C squared minus 2AC cosine B. So again, notice whatever side length we're solving for, that angle is the one that was given. So over here. And then C squared equals A squared plus B squared minus 2AB cosine C. Now, obviously, I've said, well, this works for side angle side or side side side. Well, the way this formula is laid out, this would currently only work for side angle side. So I'm going to show you the manipulation of the formula. I'm going to show you how to do it with one of them, and then I will just write out the other ones for you. So, let's see. Do it in a different, not that button. So I'm just going to take the first one. So A squared equals B squared plus C squared minus 2BC cosine A, and I want to solve for the angle. So solve for angle A. So I have to move everything over to get this by itself. So I'm going to subtract B squared and C squared. I'm going to do that all at the same time. So A squared minus B squared minus C squared equals negative 2BC cosine A. Now, all of this stuff is being multiplied, so I'm going to divide by the negative 2BC. So I'm just going to cross it out from this side and just do this to not have to rewrite everything again. So then now, to undo this to solve for this angle, this is what you did back in 7.5, I think it was. But finding the inverse so that we can solve for the angle, we're going to take the inverse cosine. So the inverse cosine or arc cosine, use those words interchangeably, of A squared minus B squared minus C squared divided by negative 2BC is equal to angle A. And so this is what you would use if you need to solve for an angle. So if you were given all three side lengths and you're going to solve for an angle, this is the formula that you would use for that. Now, I'm just going to write the other ones. I'm not going to solve them all out, but they would all work the same way. But I'm just going to write like what angle B would be equal to, what angle C would be equal to. So angle B would be the inverse cosine of, let's see, B squared minus A squared minus C squared divided by negative 2AC. And then angle C would be the inverse cosine of c squared minus a squared minus b squared over negative 2ab. And that would be solving for angle C. So these are the formulas that we would use if we need to solve for an angle. Using the law of cosines. Now, if you remember, I pointed out the other day that I think overall these are easier because these all just produce one triangle. So you're not sitting there trying to figure out how many triangles there are and all those things like you had to do with the law of sines problems. But the difference here is this math obviously looks a little bit more complicated than just like sine of A over A, right? So when we're given the side angle side situation, which would be what the formula is written up here in purple, and we're solving for the other side first. At that point, obviously, we would just be using this formula. If I'm solving for an angle, okay, if I have side, 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 and I have to solve for one of these angles, then obviously I'm going to be picking one. I'm going to solve for the angle. I typically try to solve the one that has the largest side first. Because if not, it can throw some stuff off because we know from geometry that the largest side should have the largest angle, vice versa, smallest side, smallest angle. So typically I like to start with the biggest side length because I don't know that your book has this, but there's the Algebra 2 book. There was a problem that they had on their test that came out of the book, and it was a side, side, side problem, so they had to solve for the angle. So depending on which angle they solved for first dictated what the other two ended up being. And it made it such that one of them was not mathematically accurate in the sense that the largest side did not end up with the largest angle, depending on which one you started with. So I just, as a general rule, will always start with the biggest angle and work my way down, meaning I'm going to choose the biggest side, solve for that angle. But if you've solved it out and you realize I did them in the wrong order and something just doesn't make sense, like the biggest angle doesn't have the biggest side, just make a note like, this triangle doesn't make sense, and just write why, and then just leave it. As long as you're sure your math is right. Like, I would obviously go back through and look at that, but just know that sometimes that happens when we're doing this. They wanted to know why. I really don't know why. I don't know why you can solve a problem, and depending on which one you start with, it dictates it, because the books don't ever say you have to start with the biggest one or you have to start with the smallest one. Sometimes it just happens. But all that to say, obviously, because this math is harder, right? I mean, it's not really harder, but in a sense it is. Once we have found one angle, so I have at least the sides in one angle, then what I can do at that point then is switch to law of sines formula to solve for the other angles, which makes it a lot easier. Now, if you're like, I like this formula better than the law of sines, you can absolutely use this for the entire problem. But most people switch to law of sines, and that's how I will do it. But you'll get the same answer either way. So, anyways. Let's see. In the last section, we had some area formulas. Right? We did area in the last section. Okay. But in this section, we have a different formula for area. It is the Heron's area formula. So like the bird. But I'm pretty sure it's a guy's name. Anyways. And so this is for the side, side, side situation. So the area of the triangle with side lengths A, B, and C is A for area equals the square root of S times S minus A times S minus B times S minus C. And you're probably like, is she going crazy? There's no S in the given information. Well, we have to solve for S so that I really should probably write S first, but where S is equal to 1/2 of A plus B plus C. So we add all the side lengths up and we cut them in half. And then we do the square root of that value times that value minus one side, times that value minus another side, times that value minus the other side. We take the square root of all of that and we get our area. So it's just another method. The area formulas are nice because when you know the formulas, like it's just like with the other formula, it's half of the two side lengths times the sine of the angle that you're given. And it uses all the information. If they give you three sides, this is the area formula that you have to use. Those are the only situations that we can have with this. So, actually, I'm going to stop this so I have enough